Hello to the people of TikTok and YouTube, and today I'm going to be showing you how to solve an inverse trigonometry problem using the TI-30XS or the GED calculator. So this could be a class you may have taken in high school, or maybe you're taking in college right now and you want to know some things. Well, I'll be showing you how to do all of that. So the first thing I have to ask you is, have you ever heard of SOHCAHTOA? What do you think it means? So we have SOHCAHTOA. And you probably are familiar with this if you've taken the class, but you may not fully understand it yet. Well, let's get into that. So I want you to take a look at your GED calculator, your TI-30XS, and you'll see these buttons called sine, cosine, and tan, or sine, cos, tan. So on the calculator, it would be called this. So sine, we have cos, and we have our tan. And these are basically just sides of the right triangle. So take a look at this. So on the side of the right triangle, we have our opposite over hypotenuse. I'll be showing you what this means, so don't worry. You might have to fast forward, but if you don't understand, just rewind or fast forward, it's okay. But this is what this means. So opposite divided by hypotenuse. And then we have ka, or that would be the adjacent over hypotenuse. And then we have toa, or tangent, or tan on the calculator, which would be the opposite over adjacent. So pause this. Okay, now let's get rid of it. And hope everyone's having a good day. This is the first video I made in a while, but we are dealing with right triangle trigonometry. So we have to draw a right triangle like this. And this may be familiar territory for you, because if you know what we do in some of my Pythagorean theorem video, this will actually be familiar territory. So in Pythagorean theorem, we had our c squared here, which would be the longest line or the hypotenuse. And in Pythagorean theorem and right triangle trigonometry, hypotenuse, the name stays the same for the longest line of the right triangle. But then we had our b squared, which is like the legs that hold up the right triangle. And then we have our a squared right here. But let's get into something. We're just going to go ahead and do it like this, and now we're entering the trig territory. So what is the hypotenuse again? Like I said, it is always the longest line of the right triangle. So interchangeable, like Pythagorean theorem and right triangle trig, this is the longest line, this is the hypotenuse. But we have this little 30-degree angle here. And we want to know, you might be asking, what is the opposite and what is the adjacent? Well, draw or pretend this is an arrow and it's pointing into the opposite direction of the angle. So right here is the angle, right here, 30 degrees give or take, right? Well, we don't know quite yet, but opposite of it is the opposite side. So right here, this is the opposite. So just think to yourself, if it's on the other side of the angle, well, that's the opposite. And below it, we have our adjacent. So basically, essentially below it. And let's just say that for the hypotenuse, we're given a set of numbers. So for the hypotenuse, we get 4.9. I'm going to be showing you how to do the inverse any moment now. So 4.9 for the hypotenuse. Looks kind of bad, sorry. I'm with my mouse with this. But then we're also given, for the opposite, we're given the numbers 2.8. And then for the adjacent, we're given 4.0. But this, we're going to say this is sine, or SOA. So what does that mean again? Now, in the video I mentioned earlier that it is the opposite over the hypotenuse. So it would be these set of numbers right here. So 2.8 over the hypotenuse, which is 4.9. Okay, so hypotenuse and the opposite. Okay, well, this is where the inverse starts, because we don't know the degrees of this angle right here. We don't know it. But I'll be showing you how to do this in the TI-30XS right now. So the first step that we have to do is we just follow the SOHCAHTOA formula. So we are dealing with SO here. So it would be opposite divided by the hypotenuse. So 2.8 divided by 4.9. You could use n over d2 right here, but it's okay. You can do it like this way if you'd like. But we're given these set of numbers, and we have no idea what that means. Well, the step I want you to do is I want you to click second here. Second, and then we're dealing with SOA, or sine, as I mentioned earlier. So we're just going to enter this right here, and then just enter these digits right here, these first three digits. So 0.57. And this is the same GED calculator. And just press enter. And there we go. That's the answer. But we're rounding it. And so we know that roughly that this angle here is 35. Okay, let me just draw it to the side here. Sorry. Let me just, so this right here, this little angle right here, we don't know what it was before, but we just solved it because we were given two sides to find the angle. And that angle, as we got from the calculator, is 35 after we round it. So that's it. That's how you do inverse trig. It's that easy. I'm very sorry that I skipped regular trigonometry first for solving for a missing side of the right triangle, but I'll be getting into that next. But inverse trig I find a lot easier than regular right triangle trig. I don't know why, it just clicks in my brain better. But that's how you do it, folks. So I hope you learned something, and this is either maybe something you might be doing in high school or maybe even in college now, but that's okay. And I hope this helped you, and have a good one.